One of the most important conservation laws in physics is the conservation of energy. Now, what exactly does it say? Well, it says that you can't just create energy like this, nor can you just destroy it like this. Yeah, so you can't do that. But what it does say, however, is that, well, the universe began with this ball of energy, and then this energy simply just split itself up. Okay, but this ball of energy, or rather energy itself, can go from one form to another. You can convert energy from one form to another, but you can't create or destroy it. So for example, you could convert, let's say, kinetic energy into thermal energy, right? Or you could just say you could use kinetic energy to convert it into gravitational potential energy. And nowadays, people are talking about how to harness thermal energy to produce electricity. Or in simple terms, we can just call that electrical energy. But I think you get the gist of it, right? Energy can just be created, cannot be created or destroyed, but can be converted from one form to another. And so, when we talk about the conservation of energy, how should we think about it? Now, in a system which is isolated, right? So usually we call that a closed system. When we say that, means that there are no external forces acting on the system. Then all the potential energy that you lose in this system, plus all the kinetic energy that you lose in this system, will simply be converted into some gain in potential energy plus some gain in kinetic energy. So again, consider an object falling off a mountain, okay? That is simply a loss in GPE, which is converted into some KE. Basically, it's saying that any loss in your mechanical energy, right, collectively we call PE and KE mechanical energy, has to be converted into some other form of mechanical energy. Now, what about if the system is not closed? So we call that, of course, open systems, right? So there are external forces acting on the system. Then we modify the above equation a little bit. So let's put in the original one first. We have PE loss plus KE loss becomes PE gain plus KE gain, right? But now we have two additional members here. There could be some work done on the system by some external force, right? And this work done has the potential to give you PE or KE, all right? But at the same time, there could be some external forces that oppose your system's motion, and that would be work done by the system. This could be, or rather the common culprits of this is work done against friction and drag, basically resistive forces. And so it follows that you need to lose some energy in order to do work against these resistive forces. And so there it is, a very simple way to think about conservation of energy in most scenarios.